Container services on AWS for game servers.
In the previous lesson, you learned about using containers and container services for game server hosting. In this lesson, you'll learn about container services on AWS and how they can provide a rich set of options that match different business and technical requirements for game server hosting.
If you want total control over the environment where your containers run, you can choose to host the containers on EC2 instances. All of the instance configuration must be done by the developer. AWS Fargate provisions and scales the EC2 resources in your AWS account, eliminating the need to manage instances. You don't get access or control of the individual instances. You request service at the container level and the infrastructure management happens automatically. You specify resource requirements for your game containers. You pay for resources that your game uses based on vCPU and memory consumed. Fargate doesn't handle the full range of container management activities. For that, you need a container orchestrator. Amazon ECS is a managed container service that is deeply integrated with AWS. When you use ECS, the control plane is free, but you pay for Amazon EC2 nodes, or you pay for the Fargate service, which is billed for resource usage per ECS task. You can also mix container hosting between Amazon EC2 and AWS Fargate if that's of value. Amazon ECS supports auto-scaling of clusters and the ECS Capacity Providers feature, which enables you to define game server requirements and let ECS handle the infrastructure details. Amazon ECS can rapidly launch and scale up containers to meet game demand. You can assign IAM permissions per container, and lower-cost spot instances can be used with ECS. Amazon can better innovate on ECS than EKS because ECS is maintained by Amazon and EKS is an open standard. Amazon Elastic Kubernetes Service, or EKS, uses an open-source system, Kubernetes, to provide a managed container service. One key difference between Kubernetes and ECS is that Kubernetes can be run on-premises or in a colocation data center, whereas ECS only runs in the AWS cloud. Another difference between EKS and ECS is that ECS provides more automation and EKS provides less automation and more control. If you compare Amazon EKS with installing Kubernetes on EC2 instances, Amazon EKS has deep integration with IAM, VPC, EC2 autoscaling groups, and CloudWatch, so it's easier to use. In Kubernetes, instances are called nodes, and the group of instances is called a cluster. Kubernetes determines when it's necessary to scale out the number of nodes. That part is abstracted away from you as a game developer. Kubernetes insulates you from that detail. A pod is a unit of capacity for hosting one or more containers. A scheduler within Kubernetes determines when new containers need to be launched and places the new containers on pods to meet availability and other requirements. For example, you could configure Kubernetes to keep 100 game server containers running at all times. And if a container terminated, Kubernetes would detect this event and launch a replacement. If you think of the pod as equivalent to a game server or a game session, establishing rules with Kubernetes will cause Kubernetes to do the right thing for hosting game servers. With Amazon ECS, you specify the number and kinds of tasks to run and then which containers to build the tasks from. Amazon ECS manages a lot of the complexity of scaling the service.